I'm Anil Kumar and we'll explore different ways of solving polynomial inequalities. To explain you the concept, I've taken a very simple question to begin with. The question here is, explain different ways of solving the inequality x squared greater than equal to 4. Now, first method which I'm going to discuss with you is graphical method. We can always sketch the graph of x squared, right? Which is, kind of like this. So that is a parabola. Now here we have 0. At 1 we expect 1 square is 1, right? So at 2, let us say this is 2 for us, right? Say at 2, 2 square will be 4. So we have this point as 4. Okay, 3 will be 9, correct. So this is f of x, or x square we can say, and here we have x. So that is the graph. We want to solve for x square greater than equal to 4, right? So we'll start with the equation first. So it has two parts. This inequality is greater than equal to, right? So first part which we look at is equal to. So let us find where is x square equal to x. So what I will do is I'll sketch the other graph which is 4. So if I sketch a line here at 4, this is like we can say y equals to 4. Is it okay? So that is y equals to 4. Now wherever these two graphs intersect, at that point both are equal, correct? So this point is both are equal is 2. So from here we can say that at x equals to 2, x square is equals to 4. We also notice that at x equals to minus 2 also, it is equals to 4, right? So we get one solution, which is one part of solution, which is for equal to sign. Now we are looking for x squared greater than 4. Now, which part of this graph is greater than 4? Well, this part is less than 4, right? It's under 4. But over the side, it is greater than 4. So that part is greater than 4. Now, how to write solution for this? On a number line, we will see that x values, which are greater than 2, results into x squared, which is greater than 4. X values, which are less than minus 2, also result into x square greater than 4, and therefore we get our complete solution, and we say our solution here is that x belongs to real numbers where x is less than minus 2, it is greater than 4, but we are interested in greater than equal to, so we'll include these points also. Do you get the point? And therefore we'll write here less than equal to. This is one part. The second is where x is greater than equals to 2, right? And all set of real number points which are within this are part of our solution. And that is how we get the solution graphically, right? Now this solution could also be represented on a number line. Let me show you that also. On a number line, we could write a point here as 0, a point here as 2, another point here as minus 2, and we can show our solution with arrows starting at 2 and minus 2 and going outwards, right? So it is greater than, correct? And here it is less than, right? Going outwards. Since it is equal to, we'll fill it up because 2 and minus 2 is included in part of our solution. So exactly like this, you have to provide the solution for the given question. I hope the steps are absolutely clear. So that is how you should be doing. Now let me show you another way of doing it, and this time I'll use factoring. Now this is algebraic method. Now here we bring 4 to left side, so we could write, we are solving for x square greater than equals to 4. We'll bring 4 to left side, so we have x square minus 4 is greater than equal to 0, correct? Now x square minus 4 can be factored, so we get x plus 4, 2 times x minus 2 greater than equals to 0, correct? So we use difference of squares. So it is x square minus 2 square, which could be written as x plus 2 times x minus 2, right? So that is what we used here. Now we have factored form of our polynomial x squared minus 4. It is x plus 2 times x minus 2. We are interested in all the x values which will result into positive non-negative solution, right? I should say that. Now what we realize here is that x equals to minus 2 and x equals to 2 results into y equals to 0. Is that okay? The left side equals to 0. So basically, first step is to find zeros. First step is to find zeros. So we found two zeros. One is at plus 2. The other one is at minus 2. So x equals to plus minus 2 are our zeros, right? So what we do here is we write down the zeros first. So we say zeros are at minus 2 and at plus 2. Now these zeros divide the whole interval of the plane into three parts. So within these parts we will take test points. On the left side of minus 2 we could take minus 3. In between minus 2 and 2 we could take 0. And beyond 2 we could take a point as 3, right? So these are our test points, right? These are the test points. What we need to test really is these factors, are they positive or negative? So let me write down these factors here. The first one we are writing as x plus 2. The next one we are writing as x minus 2. Okay. Now these two factors we will test for all the points. If I write minus 3 here, that is my test point. Minus 3 plus 2 is negative 1. We are interested in the sign, so we have negative here. If I write 0, I get positive 2. If I write 3 also, it is positive. For the second factor, if I use minus 3 minus 2 is negative. 0 gives me minus 2, which is negative. If I write 3, I get positive 1. So you don't have to write the value. Sign is important, right? I could have used 4. That will give me positive 2, right? 5 will give me positive 3. Important thing is positive sign. So we are considering only the positive sign, right? And now we will consider the sign of the equation itself, which is the left side. That is, when you multiply both of them, that is x plus 2 times x minus 2, what happens? At that time, two negatives will give us positive. A negative and a positive will give us negative. Two positive will give us positive. What do you need? If you see, these are our zeros, right? Which divided the whole interval into three portions, right? Now this portion was from minus infinity to minus 2. This is from minus 2 to plus 2. And then we had from 2 to infinity. Now when we analyzed, we found that the interval which gives us positive result is the one between minus infinity to minus 2 and the one which is beyond 2, right? So that becomes part of solution. Do you see that? So we get exactly the same answer which we got last time. So we can say that is our solutions, right? So our solution is same what it was earlier. X belongs to real numbers where x is between, x is between minus infinity to minus 2 or x is greater than 2, right? As I said, let me write down another way in interval form the solution this time, and that is we'll write from minus infinity to minus 2, union at times we use, and from 2 to infinity. So that is another way of writing the same solution. So what we also learn here is three forms of solution. One like this in interval, this is set form, and this is numbered line, right? So we have three different ways of writing. This is interval, that is set form, and this is number line. Okay, these are our initial values. These are our initial videos on understanding the basic concept, and therefore I am going into greater details to explain you each and every step, also different formats. I hope they help you as we move forward to correctly solve and apply the required technique. I'm Anil Kumar. You can subscribe to my videos and learn a lot. Now let's move on to some complicated cases on solving polynomial inequalities. Thank you and all the best.